In part 2 of our introductory lesson to partial derivatives, we'll continue where we left off, but before we do that, keep in mind what we learned in part 1. Remember that partial derivatives can be represented using this stylized version of the letter D, and this is read as the partial derivative of f with respect to x, and if it's with respect to y, this part changes to y. So let's continue. In question 2, we're asked, in 1941, two explorers developed the wind chill index. The wind chill is given by the function shown on your screen, where v is the wind speeds in miles per hour and t is the temperature in Fahrenheit for wind speeds between 4 and 45 miles per hour. The question is asking us to find w sub t at v is equal to 20 and t is equal to 10. In other words, 20 represents the speed and 10 represents the temperature. Let's go ahead and figure this out. We first have to find the partial derivative of our function with respect to t, and that can be represented as the partial derivative of our function w with respect to t, or you can represent this as w sub capital T. This is a constant, and taking the derivative of a constant makes it 0, so we're not going to write anything to represent 91.4. Over here what we have is negative 1 over 22. This negative came from there, and 1 over 22 represents the denominator as a factor. And remember, when we're taking the partial derivative with respect to t, v needs to be considered as a constant. So this is a constant, and so is that. So with that being said, let's go ahead and use the product rule for this. I know there are other ways to do it. Maybe we can expand this all. But if we use the product rule and we take the derivative of this part, that expression, it becomes totally 0. So all of this becomes 0 multiplied to this expression, which we don't take the derivative of, but when you multiply that expression by 0, all of it becomes 0. According to the product rule, we then add and leave this part alone. So I'll rewrite it. And now we find the derivative of this expression. The derivative of 91.4 constant is 0, and the derivative of negative t is negative 1. So let's clean this up and simplify. We have negative 1 over 22. That factor doesn't change. We know this has become 0, so we're not going to consider it. And over here we have 0 minus 1. That's the same thing as minus 1. So I'll multiply minus 1 into the parentheses, each term. This becomes negative 10.45, negative 6.69 square root of v, and positive 0.447 v. The question asks us to find out what w sub t is at 20 and 10. Remember, 20 represents v, so I'll replace 20 into here. I don't have to worry about 10 because there's no t anymore. And if you substitute these values into your calculator and evaluate this, you should end up with a value close to 1.43. This is the rate of change of the wind chill with respect to the temperature when the wind speed is 20 miles per hour and the temperature is 10 degrees Fahrenheit. Let's move on to question number 3. Here we're asked to interpret what the graphs represent. Well, as you can see in the first one, and it's not written here, but this axis is x. Notice that the x has remained constant. It's constant all throughout the y. When you make the x constant, that means you're finding the partial derivative of y. So this represents the partial derivative of y. Now looking at this one, here, this time, it is at the y-axis that we have a constant plane. So we're keeping y constant, therefore we're finding the partial derivative of x. What you see highlighted in yellow and green represents the trace of this function. And it is along this trace that you can find the tangent at any point. And there you have it. 2 more examples on how to find the partial derivative of a function. For more challenging examples, make sure you watch part 3 of this series.